Right. Hello, everyone. Thank you for joining us for the last scientific forum of this year. So today we have our third and last session for the community contribution of the OHDSI Standardized Vocabulary Series. We have Anna back again. Today we'll be talking more on the drug vocabularies. So over to Anna to give us more insights, and then we'll follow up with more Q&A towards the end of the session. Over to you, Anna. Thanks.
Anna, do I need to hold up a sign to say, yay, Anna, go, Anna? You know, because you keep coming back all the time.
Oh, you don't always appreciate it. Like, any of your initiatives is always appreciated.
You know, I gotta find those signs. You keep going, I'm gonna find my signs.
Wow. It's always such a nice thing to see Mui and everybody in person. I'm looking forward to the APAC symposium. I really am. I need to book my tickets.
Are you coming to Singapore next year, Anna? Is it planned?
Yeah, of course.
Okay.
I wouldn't miss it.
Look at that, Anna. I'm gonna hold it up just because you're here. Look.
All right. On that note, today we will talk about drug vocabularies, and it's slightly different, and I will show you why. So that probably will be quite a lot of information, but we'll see how it goes. My intention was to give you the overall idea about the process, and probably as opposed to previous calls here, if somebody wants to do that, we will have follow-up individual sessions with those individuals, because this process is slightly more demanding, but hopefully also more rewarding. So the process, why the process? I took, thanks so much for sending the examples from a Japanese vocabulary, and I will use it as an example throughout this presentation. So when I opened the file, I saw that there were also all sorts of names in Japanese, which I cannot really read, but if you take the English part of it, there is the first column, which is, you can see all sorts of different names of the drugs. And what you can see here is that they're really formatted as, you know, as you please. So you can have the brand name plus a short version of the form SUPO, which stands for suppository or rectal suppository, and then the dosage, 15 milligram. Then you can have ingredient in the second row, amlodipine, tablets. There are spaces, they can be written in a different manner. So really this, if you would approach this as just the task of mapping and run it through Sagi, what you would see is that it doesn't match well on the dosages, because, you know, dosages is just a couple of numbers and it can suggest different dosages. So the precision is really low for drugs usually, and the sensitivity as well. So one problem is that what we saw oftentimes with lots of vocabularies from different countries, drug vocabulary specifically, is that mappings are more time consuming than other vocabularies, especially if you don't want to map to just ingredient and you want to capture all of the other pieces of information. And second factor, while we want to come up with this process as opposed to just mapping this manually, is because not all of the information is necessarily available in the OHDSI vocabularies. And OHDSI drug vocabularies are historically based on the US drugs, ARC's norm. And of course, they sort of just provide what's on the US market. So for example, this first string can be mapped to diclofenac 50 milligrams delayed, oh, I'm sorry, that's delayed release oral tablet is wrong. Not even delayed release oral tablet is going to be probably just the branded drug form, even with branded drug component, even without the form, because there is no available form in ARC's norm. So what we did, we came up with ARC's norm extension, which is an extension of ARC's norm applied to international markets. And for example, you can see another example on your right, this is the mapping. 1 milliliter levofloxacin, 15 milligram per milliliter of ophthalmic solution by Pfizer, mapped from this input string that you can see right next to it. So here we can actually preserve the dosage, the volume, ingredient, form, and the what's this called, supplier. So here we in fact can preserve all of the information, and that's because we found this drug on another international market somewhere else, and we incorporated that in the RxNorm extension. And how I know that? I know that because we capture here by Pfizer supplier, and that information is only available in our RxNorm extension. So really, the process has two benefits. One benefit is that you can capture more information about your drugs, and second is that you will be able to follow more robust and more systematic process than just mapping drugs manually. And here you can see a snapshot that sort of explains in brief terms what really the systematic process is about. And you can see here that we can track a very specific detailed drug at the bottom, 10 milligram nicotine, 1 milligram per milliliter nasal spray, Nicorette, box of 5, Johnson & Johnson. We can split this very detailed drug into its attributes, and we can build the whole hierarchy up to the ingredient as well. And the very 3 bottom rows are RxNorm extension, and then the rest is RxNorm. And this process that I will talk about can be used also for two purposes. You can use it to map your drugs, and you can use it to propose drugs to be added into the OHDSI vocabularies. And I will talk about the requirements and what you need for that later, but just keep in mind that you can also use this simply to map your drugs that you have in your vocabularies. You don't have to submit a request. You can just use it, map it, and be done with it. And the process has really roughly 5 steps. And because I showed you this table with the attributes, the very first basic steps that we need to do, the step that everything relies on, is to create the tables that have the attributes. So we split all of the source records into all of the source records with the drugs into their attributes. Ingredient, then you can think of dose form, you can think of dosages, supplier, brand name, volume, and we created tables that captured this information. And because here we have a more formal process, we also have much more documentation that shows tips and tricks on how to do that, shows examples, and so on and so forth. But as a result, it's a really more demanding process, and you have to really read the documentation to fill the tables. So that would be the step 1. The second step is that we need to somehow link those attributes to the standard counterparts that already exist in RxNorm or RxNorm extension. This is where you would do what we all of us are familiar with. This is where you will map, but you don't need to map all of the drugs. You just need to map their attributes. For example, you need to map all of the ingredients. You need to map all of the dose forms. And if you have multiple matchings, we have ways to capture that as well. And then steps from 3 to 5 are done through the scripts. So this is where we have SQL files that you just run. And if you're submitting a request, what you would need to submit is the input tables in the step 1 and 2. If you're using this for mapping on your side, you can also complete the steps through 3 to 5. And essentially what we do once we have those input tables, we have a script that compare all of these input tables to the existing corpus, and we match all of the ingredients using precedence. Those form dosages. We have corridors for dosages because sometimes, there are salt and non-salt, so we have some wiggle room there. And based on that, we create the pool that can be matched perfectly one-to-one with capture of all of the attributes. And then for the rest, we create new Rx norm extension concepts so that all of the information is preserved. And as a last step, we build on the vocabulary team side or through the scripts, we build the hierarchy that joins everything together. Rx norm extension, and your vocabulary will be sitting as a source vocabulary pointing to this 2 standard. Let me actually probably at this point doesn't make sense to take questions. We have, as I said, we do have documentation with the examples, with the samples of the scripts. It points out to every step that you need to take. It's sitting on GitHub Wiki in the community contribution, only this time it's drug vocabularies. And we tested this documentation with our collaborators from Netherlands. They submitted their own drug vocabulary and they run all of the steps and tested everything and sent us the input tables, and we incorporated that in the August release. And to give you a ballpark, given the vocabulary was rather small, I would say that it took them roughly a month. Of course, not full time, just going back and forth. The whole process of discussing and setting them up took somewhere a month. So the crucial step, as I said, is the input tables. And we have 5 input tables that mimic the structure of our basic tables. The first table is drug concept stage, and this table has, it's similar to the concept table, and it has all of the information about your source vocabulary, all of the drugs, and also all of their attributes that you would need to somehow parse and add to the table. The internal relationship stage is the table that is similar to concept relationship. This is where you connect the drugs and their attributes. Then drug strength stage is the table similar to drug strength, where you store all of the information about dosages. Relationship to concept is the table where you map your attributes like ingredients to Rx norm and Rx norm extension. And finally, PC stage or PAC content stage is the table that stores the information about packs. A common example of packs, it's not boxes. Common example of PAC is, for example, contraceptive drugs, where you have to have, say, 27 pills of one kind and then 1 pill of another kind. So that's not really any box, that's very specific concept. We think of it as a very specific concept where you have to have certain number of elements in this pack for it to be considered pack. Usually it's not relevant for most of the vocabularies, but if you do have them, we can chat separately. I will not be focusing on that this time. And this is where I will switch to the templates, just to give you an idea on how you would fill those tables. And I will probably just share my whole screen. I think that's going to be easier. So yet again, I took these drugs as example, the one that I got. And the very first step is, simply orient yourself at what you're looking here. I selected some of the columns to make it simpler, and we see, as I said, we see codes. We see some names that are sort of somehow specified but not well specified. We'll also have the column that shows you the dosage plus maybe the number, not really number, mostly the dosage and the unit. There's also package, which is not really that useful because we don't use this information. And then there is a column that represents what we think of as a box size. Like, for example, here, second row, we're looking at tablets with dosage 5.2 milligrams, and the box, oh, well, the box has either 10 tablets or 100 tablets. Somebody will have to, when you go through this process, you will have to figure out which piece of information actually corresponds to which element. I would think that probably this is the box size, and this is the size of this thing that I always forget how it's called, like this individual piece of tablet sheet, let's call it
the blisters,
that.
right? Yeah.
Blisters, correct. Thanks so much. So this information can be omitted. We really don't care. We care about the total package. And we also have some root of administration, which we don't care that much about because external is just the broad root. We care about the actual dose form, which is suppository here. And we also have manufacturer name. And what I see right here is that, okay, this is the manufacturer name. Will go in as attribute. This is the box size. We need that as well. It will go in. Small package, we don't need. 50 milligrams is the dosage. We definitely want that. And we also have in the first column, which seems to be the most important column, we have the dose form. So we need to somehow parse this column to get the dose form and also get the name of the ingredient or brand name. So here it's a complicated case because this vocabulary, because you have a mix of brand names and ingredients. So somebody will have to figure out how to parse the strings and distinguish ingredient from the brand name. And potential tips just include string matches, regular expressions to essentially parse the string, and then matching to figure out if it's a brand name or ingredient. But in this first example, we have the dose form that we will need to parse, and then we have Voltaren, which I happen to know is a brand name. Diclofenac is an ingredient, but that's sort of internal knowledge. Somebody will have to make it explicit when they parse strings. And in the second row, it's, you know, the same logic. It's just the difference. Oh no, amlodine is also a brand name. Well, this row. In this row, we in fact have the ingredient levofloxacin. That's an ingredient. Then we have dose form. Then we have dosage, and we have supplier. So a mix back here, but I would write a script to parse this column and separate dosage, dose form, and brand name or ingredient. How to do that? That's a separate thing. Usually it's not that time of a consuming task. You just need to really write a lot of regular expressions. But once you separate all of these elements, you would start filling the tables. And I will be using this first row as an example. I pre-populated it to make sure that I do not forget everything. But let's start with the drug concept stage. As we said, this table contains everything, and let me make it larger. This table contains everything that we know about the drug and its attributes. So we need to, first of all, populate it with the drug itself. So we took the code from the source table, we took the name, And we also populated other supplementary fields, like we call this vocabulary somehow. So we would populate it with the name of our vocabulary. We'll also have domain ID, start dates and end dates. And there are some rules, like, for example, start date is the current date and valid end date is always December 31st and 2099. But really, all of the supplementary fields can be explained one time and you just get it. The key component here is really to populate the table with everything that you know. So as I said, we put in the drug, and we also need to, and you see, as I was filling this, I made a mistake yet again. This is domain and this is concept class. And this is a drug, so concept class is drug. And we also want to add all of the attributes. Just to recap what we know that there is ingredient, so we want to list that as an ingredient. That's internal knowledge that I got it from my head, but somebody would have to somehow infer that Voltaren is in fact diclofenac. Maybe using vocabularies, maybe somehow else, but that's probably going to be a hard part for those people who would map this vocabulary. But let's say for now we actually know that, so we populated the ingredient. We also added dose form because we want to capture that as an information. And you can see here that I assigned this dummy codes that just correspond to the name, because these elements do not have their individual codes in the source data. They just have names. So you can put name or you can put sequence, doesn't really matter. Here it's just name for the convenience. We also want to add the unit because we have 50 milligrams and the name of the supplier, which is Novartis. There is one piece of information that is missing in this table for this drug. Can somebody identify what is the missing piece of information? I'm sorry, knowledge check. I should have said earlier. So we said that this table should contain all of the knowledge about this drug.
Box size.
That would be in drug strings, brand name.
Oh,
So the Voltaren is the brand name. So in fact, we need to add that as well to the table, because if something doesn't exist in the table, it simply does not exist. So I want to add brand name as well. And let's say the concept code is the same and concept class ID is brand name. And the rules for concept class IDs are in the documentation. So this is something you don't have to remember. You can retrieve it. And the same valid start and date. There are these columns that exist as legacy. We don't really use them. For now, we will just omit them, like standard, concept, and possible excipient. But just to recap, this table captures all of this information about this drug, and you will fill it similarly for the other drugs. And if you have diclofenac, obviously you need to only mention it once. You don't have to do it per drug. It would be just one record. Now, right now, we don't know which attributes relate to which drug, right? It's just a list of everything that we have, all of the drugs, all of the attributes. So the next table we want to fill is the table that would connect the drug to its attributes. And this is internal relationship stage. And it's as simple as this. You only have concept code 1, which is always the drug, and concept code 2, which is always its attributes. So you yet again have ingredient, dose form, supplier, and this is actually not relevant. Now to the box size. Box size will be stored in DS stage or drug strength stage. this is where you list the dosages. And to remind you what we have for dosage, we have 50 milligrams and 250 pieces per box. So in the drug strength stage, it would live as the code for the drug itself, plus the code for the ingredient, because we need to mention that, the box size, and then we store 15 milligrams in the amount value and the amount unit. And there are other fields like numerator and denominator, and these fields are used for liquids. So if you have a bottle of something, or maybe you have a batch per 24 hours, or really anything where you have, or maybe powder or cream, where you have the actual volume of a substance and the amount of drug in the substance, you would use numerator and denominator. And for everything else that just has amount of the drug itself, pills, suppositories, sometimes for injections, you only will get one number, then you would also put it in amount value. You would put it in amount value. And there are actually quite a couple of rules on how you would fill these tables, like what to do with percentages, what to do if drug is missing dosage for one of the ingredients, and so on and so forth. This is all in documentation. And this is the case where you will have to read the documentation to figure out how to fill them. But the basic idea about this table is that you want to capture the connection between the drug and its ingredient and the dosage in the right field. And you may have noticed that now we have the connection between drug and ingredient here, and we also have the connection between drug and ingredient here in two tables. And we have QA checks, and you would imagine that one of the QA checks, in fact, examines whether you have the same list of ingredients in drug strength stage and in the internal relationship stage. So that's one of the checks, and they really help you once you build the input tables. They really help you to figure out what's going wrong, because they actually have a description of what the error is. In the final table, you want to, that does not work for me, oh, whatever. The final table that you want to fill is the mappings of your attributes to Rx norm and Rx norm extension, because up to this point, we don't know yet what they correspond to in the OHDSI world. And this is the first table where we actually link the attributes to their counterparts and in Rx norm. And we want to map all of the ingredients. Ingredients are the most crucial part, so you want to make sure that you map all of them. And here, for example, we map it to Rx norm ingredient diclofenac, and there is one-to-one matching. We put precedence 1. Sometimes we would see, especially for forms, and here we have SUPO, which is mapped to rectal suppository, which is a dose form in Rx norm. Sometimes, especially for forms, you can think of multiple matching. Like, for example, going back to this spreadsheet, for example, you have this row, drug in capsules. Now, this is a translation, so maybe there is some information lost during translation, but in the Rx norm, you have multiple capsules. You have just oral capsule, you have delayed release oral capsule, you have extended release oral capsule, so at least 3 matches. And you can, try to find precise match, or you can use this column precedence to keep all of these 3 potential matches and order them based on the likelihood of or the extent to which they're right, or the order of preference, where precedence 1 will be really the matching that you really prefer, 2 that you prefer less, precedence 3 that you prefer less than 1 and 2, and so on and so forth. So this table also lets you keep all of the potential matches and order them based on how you like. We also want to map, if we want to keep this information about supplier, we would map supplier to suppliers in our XNorm extension, and they only exist in our XNorm extension. They do not exist in our XNorm. And finally, we want to map the unit, and the units are always mapped to UCOM. And this is so that we can match drug strength stage to the drug strengths, and we can compare dosages. And this is where we have another column, conversion factor, and that represents what you need to do with this unit to arrive at this unit. Here they are the same, so conversion factor is 1, but sometimes, for example, you will have gram here, and to get from gram to milligram, you would need to multiply it by 1,000. So then the conversion factor will be 1,000. Yes, so that pretty much covers all of the 4 tables that one would need to fill. And I will stop here to see if there are any questions, because I know it's a lot of information. Unfortunately, it's a nice process, but it does take some effort to create these tables.
Thanks, Anna. I think
okay, Mukesh, go first. No, go ahead.
Oh, I was just saying in the chat, we have Sarkar asking about the possible usage of NLP, like named entity recognition model, whether there was used to pass this data before.
Yeah, you can absolutely use. I mean, you can use. You don't have to go through this process, obviously. If your goal is to map your vocabulary, you can do whatever you please. And name entity recognition is one of the options, absolutely. It can also be used to fill these input tables if you want to follow the process, because again, the benefit of the process is that you will have new drugs in our XNorm extension, like standard drugs, and that you will be able to do it more systematically. But regardless, NLP definitely can be used. Like you can think of name entity recognition as a task to parse, for example, this string to identify dose forms and identify ingredients. This is really where we don't provide much guidance, because different people use totally different approaches on how to match things, on how to parse them. I personally use simple regular expressions because this is where I can control it. And I know what I get, as opposed to name entity recognition, where it sometimes will try to give me something I don't like, especially when it comes to dosages. Like it would just map to a completely different dosage, because 50 milligrams and 10 milligrams, it's only 1 digit difference, which is really small error for any NLP model, yet it is a large error for us because now the dosage is completely off. Things like this. But absolutely, I mean, NLP can totally be used. If somebody would come up with a pipeline, that would be a very, very great contribution to the community as a methodology. We unfortunately have not came up with any yet. So simple, regular expressions.
Yeah, Sarkar, you might want to add on. I think you're trying to add on something.
Yeah, I was going to say, happy to do that. Give me some data.
Oh. Well, there was this Japanese vocabulary that I got, which apparently somebody wants to map. So that feels like a perfect playground.
Yeah.
Yeah, Jody, we should talk separately. Yeah. Let's see how we can contribute. Anna, a question from my side, right? So you just showed an example with 1 row, right?
Mm-hmm.
But so typically, if you are a new country coming into OMOP Odyssey and you want your vocabularies to be included in the Odyssey vocabularies, you will need to do this for like thousands and thousands of drugs, right? So how I don't imagine you can do that using Excel like you did right now and all the manual processes just now, right? How would this look like if we were to scale this to an entire vocabulary?
I did it in Excel simply for one drug, simply because I was doing this manually. But of course, if you think about processing a vocabulary, it would be, this is where I said that it's a more intense process, because here you really need somebody who can write SQL, because, or something else, but some sort of language that can do it at scale, because you absolutely cannot do it manually. And that's totally not the point. If you're doing this manually, you're better off with just manually mapping the drugs. Like, it doesn't make sense to go through all of this process. So really the idea is that you will parse the strings and put them in the tables programmatically, similarly to how, for example, you do ETL, where you take the input strings and put them in the right place in your CDM. And we have on the Odyssey GitHub for vocabularies, we have some of the drug vocabularies. For example, BDPM is a French vocabulary, and we download the vocabulary from the external source, and we follow all of these steps and get it into our XNorm extension. And create source tables is just creating the source tables, but load stage is usually where we put all of the code. And I will just show you an example of what we do. Say, for example, one of the first steps is to figure out which things are not drugs, because, you know, sometimes vocabularies have weird things like devices or insulin needles. We don't think these are drugs, we think these are devices. So we here, for example, identify devices based on the regular expression. So we're looking for something with dialysis, or something that indicates that these are isotopes and not drugs. These are considered devices. And then also adding radiopharmaceutical devices, again, some simple string match, blah, 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 and so on and so forth. And let me find something else that this parsing packages. Let me find something that is more relevant for you. So as you can see, lines and lines of not that well written SQL code. Let me put it this way. And I think I actually wrote this code. So yeah, I'm not proud about what you see on the screen. Not proud. But this is, for example, because in this vocabulary, ingredients were in the separate column, which made life much easier. Here, for example, we create this temporary table where we match drug names to ingredient names. And it's, you know, a very simple query that takes the tables and filters them based on some sort of flags that we identified in the data. And it goes on and on and on. And the actual file, doing something with units, blah, 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 blah. The actual file is embarrassingly long. It's almost 3,000 lines of poorly written SQL code. Yeah, not proud, but basically that's just trying to identify patterns. You see, there's a bad piece of code. It's just lines of code that essentially implement those rules that we think of when we look at the source data, you know, with some exceptions. So I wouldn't say it's an easy process, but this process essentially requires this process. I actually had it somewhere. Oh no. Oh no. I think I just wanted to say about it. Well, anyway, this process requires somebody who can write code and somebody who can analyze the data. And if you have pharmacists, that's nice because they can tell you what is a brand name, what is ingredient, or maybe you have other people experienced with drugs that usually helps a lot. But the key component here is that somebody has to write SQL. Really, there is no way that you can bypass that.
So for each of the tabs you had in the Excel, we would need to write up a similar code like this to programmatically populate those tables. And okay, I see. Okay, makes sense.
Let me see if there is. Oh, GMDC should be easier. So GMDC is also Japanese vocabulary, but there we have. It's nicer. Oh, for example, this is again the first step where you identify devices, and you see it's a long regular expression that looks for things that are indicative of devices, like Yohexol, Yohaglate. These are all radiopharmaceuticals that are just considered to be devices in the OHDSI vocabularies. How you would know that? Well, in fact, the documentation describes what is device and what is drug. So if we go into community contribution drug vocabularies, there are all of the steps with snippets of code. And this is, for example, a list of things that are considered devices: radiopharmaceuticals, contrast, nutrition, and the list goes on and on. So that's one of the steps here of identifying non-drugs. And let me see if I can show you any snippets of code that show how to populate the tables. Or here we clean up brand names because some of them, brand name was a separate column, but some of them are really not brand names, but just weird things like the deleted NIG price. So we don't want that. We want to remove it. And the reason why we want to remove it is because if you follow the process, whatever you input and whatever it's not in the OHDSI vocabularies will be added. So if you, for example, add this as a brand name, and obviously you will not map it to anything because there is no such brand name in ORX-norm or ORX-norm extension, this brand name will be created as the standard brand name. So that's why, it's important to do QA/QC, and it's important to proofread your tables because whatever you add will become standard. So here we're cleaning up the brand names of Wasser, which is German for water. We don't want that. And clean up of the brand name goes on, removing some junk from standard units. So that's the cleanup still. And this is where we start, for example, parsing ingredients, because in GMDC ingredients are all stored in one string and they're separated by inverted slash, I think. So we're here parsing the string into separate strings so that we have separate ingredients. So stuff like this, but it really, this code very much depends on what you see in the data and how you would process it. Does that answer the question?
Yes, Anna, thank you. The second question I had, Anna, is if you go back to the Excel and the second tab, you said we didn't have to input repetitive stuff. So for in the drug concept stage tab, you said if there is, for example, if there is, so there's gonna say, for instance, Volatran, there's multiple strengths of Volatran, right? Then we would only need to input diclofenac once, or would it need to be done for every single, so 1-to-1 to the original code?
You would input all of the drugs, all of the drugs with their codes, but for all of the other attributes, it will be just unique attributes.
Okay.
So if you have 10 drugs, you would just have one ingredient, and you can think of concept table where you have lots of Voltarens in the concept table, but there's only one diclofenac in Rx norm.
Right.
So that's structured in the same way.
Okay. Makes sense. Yeah, that's all of my questions. I'll open up to the floor in case there's any other questions from the community.
And yeah, that was on the input tables, and I will, tell you a couple of words of what happens next. And I have a couple of slides, but I will actually go right into the wiki to show you the documentation. So after you fill the tables, you want to do QA/QC. And yet again, we are talking about this documentation on the OHDSI Vocabulary version 5, wiki, community contribution, drugs. And as we go, this describes, it in fact describes the prerequisites that you need to have. So that's going to be ideally Postgres database if you want to follow all of the process. If you just want to do it partially, it doesn't have to be Postgres, but Postgres is preferred because we have functions that are fitted for Postgres. And it describes how to prepare schema, which vocabularies you need, where to place them, how to create empty tables, empty input tables, and some of the supplementary functions that we need to do to process the vocabularies. So that really, this is something that you just really need to read and follow. And this piece describes the input tables, something we just covered, plus it gives more information about specific topics, like what would be considered drugs and not devices, or what you need to pay attention to when you parse the data. And like we said, these are the types of things you want to identify in the source data. Then it goes into more details on how you would map the attributes. So really, this documentation is more or less well written, and it has more information about how to do this. It also describes how to fill tables, the rules, what goes where, blah, 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 blah. It has more information on how to fill DS stage. When I said something goes into amount and something goes into numerator, this goes into more details on how to actually fill the tables and what rules you should use. And then finally, the last step here, as I said, is to perform QA/QC checks. And this is important because it really identifies the problematic places. Like, for example, dosages cannot be without units, right? You always need to have some sort of unit. It cannot be just 50, because 50 milligrams, 50 milliliters, not clear. So we would flag that. Or doses above what is possible. Or sometimes it also checks for doses. I'm making some notes. Or sometimes it even checks for the content itself. For example, solid forms like tablets cannot be in milligram per milliliter. It cannot be liquid dose. So it would check for that as well. And we do see vocabularies even official vocabularies coming from France or other countries that would have tablets with milligram per milliliter. So we know these problems exist, and we want to flag that as well because it doesn't make sense. Tablets cannot have milliliters. And these are the scripts that you would just run on your input tables, and it will output the error, the count of error, and the description of what went wrong. And then the other steps are designed for those who really want to go all the way in. For example, if you want to use this approach to map your vocabularies and not even proceed, just map them, you can also run the whole pipeline with the boiler, which is the script that actually does the matching and builds our XNorm extension. And this section describes on how to run it, where to get the scripts, and how to process it. So, and it goes all the way up to manual ancestor. So to those people who are the most proficient and want to make sure that everything is correct, you can go all the way up to creating the hierarchy, and you can even examine the hierarchy and use it on your local site if you want to. And some more checks. And as you can see, it's a lot of information and a lot of links to the scripts. So as I said, it does take quite some time. As a result, you do get a systematic process that you can repeat when the vocabulary refreshes, when new drugs enter the market, and you need to do it once, and all of the refreshes is much, much easier. And we did this exercise with our collaborators from Netherlands. They said it took about 1 month to get it done. And we also done the same exercise for Korean vocabulary, Korean drug vocabulary, maybe a couple of years ago. And there it was a lot of, back and forth. We sat together, we looked at the data, we helped them fill the tables. So it was a lot of involvement at different stages. And there it took us all together, given that we had full-time jobs, maybe 3 months or something. So this is sort of the ballparks of how much effort and time is needed to run this thing. But since then, we are updating Korean drug vocabulary on a regular basis, more or less. Yeah, this is where I would stop.
Thanks, Anna. Are there more questions related to the vocabularies, the drug vocabularies in particular?
All right, so we do have, it seems that we do have at least one candidate for such an approach. It's of course up to you. You can totally decide that this is too much work or you don't feel comfortable, and that's absolutely fine. But in case you decide that you want to test it out and see how it works, that probably would be a good candidate. And I feel that name entity recognition would be also very useful here for parsing the strings as well.
Yeah, Joydeep dropped off a bit earlier, Anna, so I'll make sure to convey that comment to him. So hopefully we'll talk about how to potentially use NER as well. So yeah, if there's no questions, I think we're right on time. I think one small announcement, guys. The community call for this month is next week. So typically it's 2 weeks after the scientific forum, but because of end of year holidays and everything, we've decided to take it 1 year, not 1 year earlier, 1 week earlier. So community call is next Thursday, same time as today. And once again, a great round, a big round of applause to Anna for her 3 series, right? 3 series, the series on 3 sessions on Odyssey vocabularies. I think it's helped both myself and the entire community to understand the vocabularies better and how we as a community can make contributions. So, and as Anna recommended at the beginning of the call, maybe we'll have one session where we have Mukesh from A-Star to share his organization's experience on working with the templates that Anna shared about in the recent sessions in the recent months. So yeah, so Mukesh, can you take the floor now? I'll shut up now, and we can close the call.
Thank you, Song and Anna. Yes, definitely. We've been working with Anna on our Gusto use cases, in particular on the genomic space and the Gusto cohort as well. So the initial discussions have been helpful to steer us in the directions forward. Like just to give a quick glimpse is for the genomic, we're looking at the non-standard concepts. So working with the oncology working group, we're trying to build together some standards right now. And we're trying to propose that as a use case that can work for Singapore. And we are looking into using the CleanGen framework. We're doing this looking at clinically relevant variants rather than every variant out there. The other angle is about adding data vault as a dictionary. We're trying to harmonize Singapore's epidemiological cohort studies using the data vault. So that may potentially involve us uploading the ontology onto Athena to help the rest of Singapore community. So it's something we're doing for Singapore together with OHDSI. We'll be happy to share that more in future sessions, how our Singapore team is doing. Yeah. But thanks again, Anna, for all your guidance there and getting us through this. Yeah.
All right.
Okay. All right.
Thanks, everyone.
All right. Thank you, everyone. See you soon.
Thanks so much.
Bye.